This video is going to be for Design and Communication Graphics PN 4025 Week 2. Okay lads, this is going to be your very first lab for Design and Communication Graphics module this semester. Throughout the semester we're basically going to be dealing with plane descriptive geometry, which is a Leaving Cert cycle topic. Now each individual lab is going to deal with a subsection of plane descriptive geometry, the first being first and second auxiliary projection, as you can see here. Now basically throughout this lab itself we're going to be dealing with some of the key concepts in relation to each of these topics. This first video in each one of the labs is basically going to run through the structure of the lab itself. After this video is completed, you're expected then to work further down along this site itself, which will go into a bit more detail in some of the sections that we talk about during this video. First of all, what I want to talk about is first angle projection. You should all be familiar with first angle projection now. It's our European system for displaying views on a page. We have an American system as well called third angle projection. If you don't know the difference between the two, give it a quick Google search or a quick search in Google Images, and it should give you plenty of information to see where all the different views are derived from. What we're going to be worried about anyway is our first angle projection. As you can see here, you can see our elevation, you can see our, which is known as the front here, and you can see our left view, which is also our end view, and our top view, which is our plan. Now the main thing to notice here is that basically when you're viewing the object from the left hand side, that is projected onto the right hand side. So basically you see what's on the left projected off to the right, you see what's on the right projected off to the left. That's the main thing to recognize here. As well as that, you can see the symbols for the projection systems down in the left hand corner. You can see there basically how to draw this symbol. As well as that, you can see how to draw the third angle projection symbol. We're just going to focus on the first angle projection symbol. It's important for you all to note how to draw this and take it down somewhere, so that if you ever are completing a drafted drawing for professional use, that this is a symbol that you will need to have added in on your drawing to meet basically the standards of the European system. Now first of all, I want to talk about the true length of a line. So you can see here the red line there, that's the line we're going to be talking about, and we're viewing it from the elevation. Now if I was to ask you, is this the true length of that line? And what I'd be hoping that you would tell me is that no. And the reason for that is that, you know, it might be, but we don't have enough information. Giving us just the elevation is not enough. So if we were looking back here again at our first angle projection system, you can see that we have our three views: our elevation, our plan, and our end view. Now for this, if we have our elevation, it's just not enough. We don't have enough information there. For instance, if you were a builder and you were just given the elevation of the plans of a house, that'd be no good for you. You would need to see a plan view as well, or even an end elevation, to get all that additional information that you're missing here. So the same thing applies. So if we go to SolidWorks model I have here and just look in on the elevation, so look on here. Now this green line is basically representing that red line from before. John, I'm going to change the color of it. Change to red. There we go. Okay, again we're going to look in the elevation. As you can see here, this is representing the same line as we were looking at before here. Now same thing applies. Is this our true length? Now if I get my additional information and look down plan, I can see that no, it wasn't, because it's actually distorted in both views. You can see it's at a bit of an angle. So if we look at it in elevation, it's not our true length, and if we look at down on plan, it's also not our true length. So what we need is our auxiliary view. So basically today's topic. So using the auxiliary view, we can look at this at an angle that we can actually see it as a true length. And to do that, we need to look at this line perpendicularly. So what I'm going to do is, first of all, I'm just going to draw in our two lines on our elevation, our plan. So basically these two lines represent that as you're looking in from each angle, like so. Now, like we were saying before, these are both not true lengths because they're distorted. So what we need is our auxiliary view. So I'm basically going to add in a line here that when I'm looking in plan, now we could also do this in elevation, but first of all we're going to do it in plan. A line here which is actually parallel to the line itself that we're looking for the information off of. Now when we add in a plane, like so, there, and if we look directly in on this plane, we're going to be now looking perpendicular to that line itself, because remember these two are parallel. So if I look in on that, so I'm looking perpendicularly in it. Now this line here, we're actually seeing it as a true length. So if I project this back, make sure I'm like so. If I project this back onto that plane, now what we have is our true length here represented. Okay, while we didn't have our true length here in our elevation or our plan, we have it represented properly here. Okay, so if I was actually to measure this and I was to measure this, it would be the same, while if I was to measure our line back in our elevation or our plan, it would be different. So now if I just jump back to my PowerPoint slide, swap this across, and I have a look at my next slide here. So basically what we're looking at is true lengths of lines. So first of all, we're just going to focus on this first image here in the center. We have our elevation, our plan of a line again. The line is called AB, as you can see it here in elevation, and it's AB as well here in plan. Now, like we did before, both of these are not true lengths. And a quick way just to know that they're not true lengths is, for example, that AB is not parallel with the XY line here, so it's definitely not going to be a true length across. While if we use our auxiliary view, so our additional view, again, putting it parallel to the line. Now you could do this in either plan or elevation. We're going to do it first in plan here. Have it parallel, call it x1, y1. Bring our lines perpendicular across. Take our heights from our elevation here and here and take them over. Now we have our true length here. Now like I was saying, you can also do that in our elevation. So the same drawing again here, line AB in elevation plan. Now taking the auxiliary view from elevation, x1, y1. Taking perpendicular lines across and taking our heights from our plan over across. And this will be the exact same length as our green line over here. Now you can see this happening again in a quick sketch that I put together where the line is just at a different orientation, but you can see again AB in elevation and plan are both not parallel to our XY line, while in our auxiliary view that we're adding in, it is parallel. Lines taken perpendicularly, heights taken from our elevation, and we get our true length again. And then you have just a bit pictorial here that helps you understand what's happening. So now auxiliary views can also be used to find true shapes. As you can see here, there's another bit of pictorial. You can see here there's a little Lego man. But first of all, let's look at our VP and our HP here. Our VP is just our vertical plane. Just think of this as your elevation, and your HP, our horizontal plane, think of that as your plan. Now as we're looking in here on the VP, our elevation, this surface here in red, we know that's distorted because we look below here in plan, it's at an angle. While if we take an auxiliary view again, and if we take it from our plan here, ensuring that our x1, y1 line is parallel with the surface itself, like so. And then when we take our lines across, take our heights from our elevation, we end up with this shape over here, as you can see in our pictorial view. And you can see that as you're looking in from this angle, so this additional view, this auxiliary view, you can actually see the true shape itself. Now it's important to remember what the actual definition for auxiliary is. I actually just pulled it here out of Google search. So it's providing supplementary or additional help and support. So that's exactly what our auxiliary view is doing. It's giving us that additional viewing angle that our main three angles weren't giving us that bit of information from before: our elevation, our plan, and our end view. So now if we also, I have a video here of a physical model basically explaining the same concept as we talked about here, using an auxiliary view to find that true shape. Now if you work your way down along the site itself afterwards, you'll be able to go through this as well as in the slides up on Solus. And in that video, this is basically just a screenshot taken from it over here on the right hand side. It basically walks through this model itself. I've also added in this image here on the left hand side of basically the drafted solution of what I'm doing on the physical model, what I'm basically explaining. So then you can draw the links between the two to get that bit of deeper understanding of what is happening. As we move on, here we're going to be dealing with first and second auxiliary projection. So before we were just dealing with basically a first auxiliary projection, so one additional view to help us find, let's say, our true length or our true shape. Now we're going to be bringing in our second auxiliary view, which for this case is going to be helping us find a dihedral angle. And if any of you are not sure what dihedral angle, it's the same thing as a true angle. So it's the official angle basically between two surfaces or two lines. Now if you were to look at this at a distorted view, or if it wasn't in the right position, you wouldn't get the actual dihedral angle or the true angle itself. You'd be getting a distorted view, so the angle would actually be off. So in this, basically you have this object here in your elevation and in your plan, and then using your first auxiliary, basically finding the true length in between two planes, and then looking along that true length to find that dihedral angle. Now I want to basically walk through this solution with you to get you a bit of understanding how the two views are created, as well as how they actually work. So what I've done is, first of all, I have put together a digital model and I've saved it on Solus as a SolidWorks file, as well as an e-drawing file that you can manipulate to view where each of these views are coming from. So each of these individual views, our elevation, our plan, our first auxiliary, our second auxiliary, it all can be seen here within this model. I suggest you'd open it up and have a look at it and manipulate around, have a look from where all the views are coming from, where all the different hinging points are, to basically allow you to create a view such as this one. Now, as well as that, I have a video here walking through the drafted solution of this itself. So from the start, I do the elevation, the plan, the first auxiliary, second auxiliary, explain through each of the principles, each of the things I'm doing to find each of the key parts of this drawing. Now this is a very important one for you to go through, because it's a common question to be asked to find the dihedral angle, because it tests first and second auxiliaries all in the one. So just ensure that you take your time, you watch it, you look at that physical model, as well as work along with the drafted drawing with me. If you want, I've also added in this question sheet on Solus that you can complete if you need that extra bit of support. If you feel confident, that's fine. Just watch the video and you can work on the activities afterwards. Now we have two activities. So we have this one, as you can see here, and it's going to be up on Solus, and our second one you can see here, and then this is the sheet itself, which is also up on Solus. Just print them out, attempt them, just ensure that you're applying all the knowledge that you've gained from the lab itself, as well as those videos and then models that I've provided you with, to try complete these. Now the first one you should be fine with, this one here. The second one's a bit tougher. Keep working your way through them. Hopefully by next lab I'll have a bit of a walkthrough of the second one here for anyone that has a small bit of trouble getting completed, but everyone should definitely have a good attempt at completing the first one. They're very achievable if you follow all the steps that basically are completed in the first example that I showed you above here. You should be absolutely fine. Now for your third activity of this lab itself is going to be an A3 principle sheet. Now each week you're also going to have these principle sheets along with each of the topics. Basically what they're going to be doing is they're going to be on whatever topic you have that week, which this one is first and second auxiliary views. In this principle sheet I want you to hit off about finding the true length of a line, finding the true shape of an inclined plane using one auxiliary view, and finding the true shape of an inclined plane using two auxiliary views. All these should be hit off in your principle sheet. This principle sheet itself should be contained to that A3 size. It is a digital principle sheet, so that means it's going to be handed up digitally. What I want you to do is to be able to explain first and second auxiliary views hitting off these three different points to a good amount of detail, that if someone that didn't already understand first and secondary auxiliary views got this sheet, that they would have a better understanding for how they're completed after reading through it. You should be using SolidWorks models, AutoCAD models. You can even embed videos if you want to. You can have physical models dropped in there. You can have voiceovers. You can have voice clips. You can have sketches. You can have notes. Anything that you think would be appropriate to explain how this first and second auxiliary views work, hitting off these 3 points here. Now, I've just added in here an example of an auxiliary projection principle sheet that was actually my one when I went through this module. Now, things have changed. We're going for the digital this time, so you're going to be expected to have that small bit more of an interactive sheet. By no means is this a perfect solution for what I'm asking for. There's a lot of things that I would change now if I was to redo this 4 or 5 years later. So just ensure that you were thinking about this, you were working your way through it and providing the best solutions as possible to basically show students how auxiliary projections work. I've taken away information here just in case anyone decides to paste and copy things across. As well as that, any images that I've used here, feel free to recreate them if you think they're going to be beneficial to your discussion, to whatever you're going to build as your A3 principle sheet. But just ensure that you do not take any of these images directly. It's plagiarism. It's same for any one of you. If one of you makes a drawing and 3 of you are sharing the same drawings, that will not go. That's plagiarism. That will be reported straight away. So just ensure any work that you complete is your own. Any physical models that you use are your own. It all has to be your own work. I don't want to see basically shots taken out of, or pictures taken out of books and things like that. If you were going to make a model or show off a sketch or anything like that, just ensure that's all your own work. Past that, lads, if you have any questions in relation to completing one of the drawings or the activities that we've done in this week's lab, there's them 3 books that I'd recommend for you all to have and look through, which will help you understand these topics, especially David Anderson's book. It's going to be key to you. It's covering every topic that we're going to be covering this semester in plane scripted geometry, so just ensure that you have that book. It'll be very beneficial to you. After you've consulted these and you're still not too sure and the week has passed, ensure that you come and send me an email and ask me any questions that you might have. Just ensure that you have it structured in that email in such a way that I can help you straight away and I don't need to be sending 4 or 5 emails back and forth before we understand what actually the problem is. After that, lads, work away through it. If you have any questions, be sure and ask. Put it up there either on the Google Forms that we'll have added on the site here, or ask myself directly by email.